This next example comes out of section 10.3, composite functions. This is kind of our backwards example, meaning that in this case we're given the composite function. We're told that h of x is f of g of x, and here it is, and we're asked what the two components to that could be. Anytime in math where you're given one answer and you're asked for two possible components to it, you actually have lots of possible answers here, but your simplest response is usually your best response. So in this case, just as a sample, if I said that f of x was just x squared plus 3x plus 2, and I then said that g of x equals x plus 5, hopefully you can see how g of x just replaced the x in the first function. So if I have now x plus 5 squared plus 3 times x plus 5 plus 2. Again, more answers possible, but that's probably the best, most straightforward answer. This is a skill that becomes especially useful for those of you going on to Calculus Math 31. There are lots of places in doing derivatives and some of the derivative rules where it's very useful to see something as a function of a function and to be able to get at it that way. The second question has a couple of pretty good answers to it. We could say that f of x is just to take the square root of something, and g of x is that something is x cubed plus 8, and that would work perfectly well to give us that f of g of x is what we're given there. It is also possible to look at this in a different way, which is pretty much just as simple and just as good, to say we've got f of x equals the square root of x plus 8, and then g of x is just x cubed. So we would put x cubed in for x, and we'd end up also with the function that we have up above. I don't see one of these as any better or less complicated than the other. And I mean, like I said, you could come up with all kinds of weird and wonderful contrived answers, but these are both pretty direct answers given what we're given in that problem.